Hi, my name is Stewart Lynch, and in this video, we're going to be taking a look at the SwiftUI ViewBuilder parameter that lets you construct views from closures. If you don't know what that means, think of it as your own custom implementation of something like an HStack or a VStack, in that you can define how you want your views you provide in the closure to be presented. We'll start off with a basic use case and then explore two practical examples, including container views and a heads-up display view. Before I get started, please make sure if you enjoy this video to leave a comment below and give it a thumbs up and subscribe to my channel. Make sure you ring the bell to be notified of new videos. If this is something you want to learn, then keep watching. For this video, I've created a starter project that is simply a tab view containing 3 views where we'll be implementing our 3 examples. As I mentioned, we'll be starting with the basics so that you can understand how to implement the ViewBuilder, and I'll follow that up with an example of creating and using a custom container view, and then we'll create our own heads-up display or HUD that will present some kind of alert and then disappear. So let's get started. In the first tab, I'm going to create a button where the label will either be a rectangle or a circle depending on the state of a Boolean value. So let's start by creating that Boolean value that can change as a state property. We'll call it isSquare and set the initial value to true. Now we can create our button with the action that will toggle the value of isSquare. And for the label, we can use an if-else clause to decide what kind of view we want to present as that label. So if isSquare is true, I'll create a rounded rectangle with a corner radius of 10. I'll set a fill of color green, and I'll set a frame that has a width and a height of 100. For the else clause, I'll create a circle that has a fill color of red, and I'll set the frame to a width of 100. If I preview now in the canvas, as I tap on the object, the shape and colors change as expected. Now, one of the design principles of SwiftUI is small view structs. So why don't we extract our label into a utility method as an extension of our view? So first we'll create the extension for basics. And now we can create a function that has no arguments but returns some view. And then we can cut out our label's if-else clause and paste it in there and replace the cut with a call to that function. The function, however, generates an error. It declares an opaque return type but has no return statements in its body from which to infer an underlying type. Well, the views are different, and even if I did add returns, we'd still get an error. Well, there's several ways to solve this problem. I could enclose this in a group, and the error goes away. I could also, as I said before, add a return before each of our views, but I'd also need to enclose these in any view to perform type erasure. And that way it gives both of our code branches the same return type. As you can see, this is working fine too. But there is a better way, and that is simply to decorate our function with the ViewBuilder attribute. So let me remove the return and the AnyView enclosures, and I'll add the @ViewBuilder to our function definition. Again, this is working as we hoped. For completeness sake, I'd be remiss if I didn't present an option that most of you would have probably used, and that would be to, instead of creating a utility method, to extract this as its own view, and then pass in the Boolean value as a binding. So let me comment this out first. First, I'll create the view, and now a binding to the isSquare Boolean value. And then for the body, I can paste in the code. And then for the label, I can simply use this view with our isSquare property as the binding. This works too. Which method you use is up to you. I prefer to use the @ViewBuilder option for generally isolated views like this one, and to extract to a full view if I want a reusable component. On this second tab, I'm going to take a look at the @ViewBuilder in the context of a container view. So what's a container view? Well, in SwiftUI, you use them all the time. This is what a VStack and an HStack is. Let's embed our text view in a VStack and add a second text view with some text. If I Control-Command-Click on our VStack, I jump directly to the definition. And in the definition of this struct, we see that it's initialized with our content as a closure, and that closure is decorated with the @ViewBuilder parameter. Well, we can use this information then to build our own container views with ViewBuilder. It's simply a struct, and we can give it any name like VStack or HStack, but I'll call mine myContainer, and it will have to conform to the view protocol. In addition to that, however, we'll be providing our struct with some content, which must also conform to the view protocol. So we can use generics here by specifying a placeholder that, instead of giving it the normal T designation, we'll use content with a capital C and make sure that the content also conforms to the view protocol. And then within the body of my struct, we'll create a property that is of type content, capital C, which is our generic type. We'll need an initializer for that content, so we can specify that the content will be a closure that will return our generic content view. And then we can set our content to this content closure. The one thing we must do in addition, however, is to also add the @ViewBuilder parameter just as we did for our first function, so that whatever we return as content will be able to be handled. Now, because the struct itself conforms to the view protocol, there must also be a body property that returns some view. So let's just return the entire content because it conforms to a view protocol. This then is the basic building block for our container view. This content is whatever I pass in via the container closure. In our VStack example, it was these two views. So instead of a VStack, let's change our container view to a myContainer. This means then that we can treat whatever we pass into this struct as a single entity. We still have the same limitation that we had on VStacks and HStacks, being that we're limited to 10 views, but we can play around a bit here. What if I wanted to embed this container itself inside a VStack? This does exactly what you'd expect it to do. It embeds both of the views that were passed in into a VStack, and we get the same result as we had initially. Let's add some padding to our content, a padding of 5. How about adding a background color to the VStack of a rounded rectangle with a corner radius of 10 and a fill of color green. We can also set a foreground color to white. And then how about adding a shadow with a radius of 5? Now at this point you may be asking yourself, well, what's the advantage to this? I could have just as easily applied these modifiers to our original VStack. However, we now have a reusable container view that I can use anywhere. So what you say? You could have done that with your own custom view. But could you have done this? How about we add another view to our container, but this time not a text view, How about a button? And for the label, let me set an image, a system image of star. If my container was a simple view, we would have had to specify exactly what number and type of views we wanted in that VStack. With the ViewBuilder, we can decide at the top level, so as long as we don't exceed the 10 views, and the modifiers that we apply to our content will apply to all of the views that we have within our closure. Currently, this My Container view only has a closure, but you may recall that VStacks and HStacks, which are view builders, also have optional arguments like alignment and spacing. So what if we wanted the background color to default to green and the foreground color to white, but have the option to provide a color for the background and or the foreground? Well, that's easy. We just add new properties to our My Container, one called BG color of type color, and the second FG color of type color. And then in the initializer, we can assign our default values of green for BG color and white for FG color. And then instead of the hard-coded fill in our background's rounded rectangle, we can replace it with BG color. And the hard-coded white foreground we'll replace with FG color. This doesn't change what we have in our canvas preview. Let's test this out in our original body by embedding our My Container view itself in a VStack and add a second My Container as the second view in the VStack. This time though, for the second one, I'll set a background color to red and a foreground color to yellow. And for the views that I'm going to pass in, I'll have one that will be a text view. And for the second, I'm going to pass in a rectangle with a fill of color yellow. And I'll restrict the frame to a width of 200 and a height of 50. Now we have a pretty flexible container view using a ViewBuilder. So let's move it out now to its own file so that we may be able to use it in our final example. I'll cut out the view from here, and I'm going to create a new Swift file that I'll call My Container. I'm going to have to change the import to SwiftUI, and I'll paste in the code. Now, if you wanted to have a preview for this view, you can do that by creating your own preview provider. And then in the preview, just submit 2 random views. But make sure you enclose them inside a My Container ViewBuilder. For our final example, we're going to create a container view that we can use as a heads-up display. So let's start by creating that generic ViewBuilder as we did in the previous example. I'm going to call the struct HUDView, and it'll conform to the view protocol, and we'll be providing it with some content that is generic in nature, but it too must conform to view. And then the content property is of type content, and we can initialize that as a closure that returns this type. And we'll have to make sure that it uses the ViewBuilder decoration. And again, because our struct conforms to the view protocol, we have to have that body property that will simply, for now, display the content provided in the closure. Now, this is how we start every ViewBuilder that you want to create. So I've created a snippet for that myself, so that all I have to do is type SW_VB and then provide it with a view name. Snippets are great, and if you're interested in the power of snippets, I recommend that you watch my video on that topic. I'll leave a link in the notes below. So for now, let me just embed that text view in our original body inside my new HUD view container. And while we're at it, in our HUD view itself, let's embed the content inside a My Container view. Now, for my heads-up display, we want that background color to be a secondary system background. And the text, which is our foreground color, we want it to be secondary label, so that this is going to ensure that it's going to appear nicely in both light and dark mode. And then next I want to embed the entire My Container inside a VStack itself with a spacer to push it up to the top. Now back in our current views body, I only want this HUD view to appear when some action is completed, or if I tap a button. So that means we'll need some kind of Boolean state variable that we can change. So let's create one that I'll call isShowingHUD, and I'll initialize it as false. So in the body, we'll need to create a ZStack so that this view is only shown if isShowing is true. And so in the second item of the VStack, I can create a button that will toggle that state. Now when I tap that button, the heads-up display is displayed. That's not too exciting. I could have done that with any view. What I want to happen is, I want it to slide down gradually from the top, and I also want it to dismiss itself after a short period of time. But there's another problem, and that's the way I've positioned this HUD view in my ZStack. It's behind the second view. So if this view were more than just a simple button, like let's say we embedded this inside a ZStack itself and added a color as the back view of this button. Now when I tap on the button, our heads-up view is hidden behind the green color view. Now I could have fixed this by moving the if clause below the other view to make it our first one in our ZStack. But better than that, I can go directly to our ViewBuilder and say that I want this HUD view's z-index to be 1.0. This will force it to be always on top inside the container. Now I can work on the animation by adding a transition and an animation. Now the transition will be a move where the edge is from the top. And for the type of animation, I'm just going to use a simple spring animation. Now when we tap our button, it springs down from the top, and when I tap again, it goes back up. We're almost there. What I want to happen now is that after a short delay, I want it to disappear without me having to tap that button. This means we're going to have to toggle that state variable somehow. So we'll need a binding to our ViewBuilder for that and add it to our initializer. Now because isShowingHUD is a binding, when we initialize it, we'll initialize it as a binding to a bool. And then in the body of the initializer, we don't use a $sign. Instead, we use an underscore when assigning our isShowingHUD parameter to our binding. With that, then, we can add an onAppear method for the VStack that will use a dispatch queue.main.async after. And with that, we can set a deadline of 3 seconds from now, and then set the isShowingHUD back to false inside a with animation block. And that then will dismiss the HUD after 3 seconds. Then the last thing we need to do then is to pass in that binding to our state variable when we create our HUD. Testing this now, we see that the HUD displays when I tap the button, and then after 3 seconds, it moves back up out of view. Now remember that our HUD view is a view builder, which means that we can pass in more views to our HUD view to provide more information. For example, we could just add in another text view. Now I chose to use my container view within the HUD view ViewBuilder. So if you want to use this in your own project, you'd have to either add this HUD view to your my container view file or create a second file for HUD view and include both. Alternatively, you could do a better job with the HUD view by adding all modifiers to the content within the HUD view itself and have no dependency on the my container view. The sky's the limit for you now, and you can create some pretty powerful reusable views. Now, if you're interested in taking the HUD ViewBuilder even further, I recommend that you read this post from Federico Zanetello's FiveStar blog. This takes the concept even further to reduce your code. You can always learn great things from the Swift community.